Sam, are you still there? All right. I'm not sure how many people are watching this, but we got kicked off of one Zoom, and we're now trying to make it work on another Zoom channel. And hopefully my colleagues will get back on. Although anything goes, because it's been a very crazy year, as everybody knows, and all the more so with the wildfires that are occurring here in Jackson, Wyoming. So I've got two live streams right now. I'm going to put a link to the shareable account here. I'm going to view live on YouTube and see if anybody's there. And hopefully my co-host will join very soon. My guest will join very soon. And I see some of us are there. And hopefully it came up, started streaming 62 seconds ago. So hopefully that works. There I am. Okay, so we're now waiting for our other guests to show up. Maybe they will, maybe they won't. We have plenty to discuss regardless. And the only other thing I can think is that maybe they are waiting for me in the Zoom room, but this doesn't look particularly promising. So let me see if they will come on. We have 91 watching now. So I'll get edited out, don't worry. Let's see. Got an error message. Oh, all right. Let me see about this then. I'm going to invite. Invite Sam Singer, who is the proprietor of Wyoming Stargazing. Copy invite link. And here we go. Let's try this. Right. Okay. So now this should work, and we will get some lovely guests joining us. I want to just say how cool it is to be able to see and use this enormous telescope facility, even in the midst of this corona plague that we are all experiencing, wherein all international astronomical star parties have been canceled, sadly. But fortunately, we have the ability to connect virtually. And I think that's quite spectacular. So let me see if my friends can get in, and hopefully we'll be able to go live there. Let's see, we got him as live, and here we go. So I am going to check out the star images that I have obtained from this telescope. Good. All right. Good. So I have a set of images that we're going to go over, and I'm going to share them with you. And again, this is celebrating a couple of things. One is celebrating the first example of the Hubble telescope's major contributions to astronomy. And I think the best place to start with that is one of Hubble himself, Edwin Hubble's first spectacular images that really set the world aflame, if you will, to really demonstrate for the first time that we were an island universe within a much, much larger universe. And here is an image taken by a composition of images taken by the Hubble Space Telescope. And this phenomenal image has really revealed in startling relief the glory of what Hubble himself first kicked off about 97 years ago. In 1923, Hubble discovered a Cepheid variable, which is a pulsing star located somewhere around here in the Andromeda Galaxy, which he initially mistook for a simple nova, that is a flaring star that goes on and off of regular periodicity, that Henrietta Swan Leavitt had determined could be used as a type of ruler that we could use to measure all the way out to the Hubble, to the Andromeda Galaxy, which is located about 3 million light years away from Earth. And by counting the pulsations, if you will, and observing this phenomenon over the period of October of 1923, Hubble was able to determine that this was actually located at tremendous distances, much farther than the known extent of the Milky Way galaxy. Because of that, Hubble was able to establish once and for all the answer to the question whether or not the Milky Way is a galaxy or whether or not it was the entire universe. And that was the subject of what's called the Great Debate. So some of these images were taken with Hubble, and some of the next images I'm going to show you were taken by Mike Adler's camera. This is a nebula. This is a raw image made from relatively long exposure. And that exposure, there's Mike coming in now. Hi, Mike. Can you hear me?
I can.
Great. So we're reviewing on the screen now.
Oh, wow. Yep.
Yeah, one of your images that you took. I think this is this the Veil Nebula. Which nebula is this?
No, this is the Bubble Nebula.
The Bubble Nebula.
And it's a very interesting nebula because it's surrounded by hydrogen gas. In fact, this is a bubble of hydrogen gas being essentially inflated by the bright star right here. And Samuel will have a series of pictures of this nebula that are done in different ways. For example, there's a narrowband image in the Hubble palette, which will be largely green. So I don't know, Samuel, you want to show that?
Yeah,
I made you
up in about 20 seconds.
And Mike, are we able to look at the look through the telescope currently at Jupiter or Saturn, or is it
Well,
too
I was looking at it earlier, and it just looks very faint. I don't think it's bright enough to actually show up tonight, I'm afraid.
So Sam, first, why don't you show the image of the before and after the current quad state area wildfires? That would be a cool image to show.
Sure. Yeah, let me share my screen once I get that image up. And
Yeah.
All right.
one sec here.
Hey, Tony, are you back?
Yeah, we're back. And I need to turn on my video. Sorry about that, Brian. Didn't mean to mess it up for everybody.
It's okay.
Not a problem, Tony.
Yeah, really is sorry.
So here's
about
what we're
that.
working with tonight, folks. On the left is generally the view of the mountains out in Kelly, Wyoming, a few miles from where I live. And on the right is a picture that was taken just about an hour and a half ago. So you can see we are pretty socked in with smoke from mostly the California fires right now, some in Idaho as well, but the prevailing winds just bring the smoke from the west right over those mountains and settles in the valley.
Yeah, I came to escape the wildfires, but it's not working out for me, unfortunately.
You've escaped the fire, but not the smoke, unfortunately.
That's right.
How far away are the fires?
In
And they're a long way
Jackson?
away. They're
800,000 miles away, but
Okay, so these are the fires from California then, not fires there in Wyoming.
There's a fire in,
Yeah.
in Utah. I've heard
That's
there's
right.
a fire in Colorado.
Oh, okay. I thought these were
Yeah.
fires in the state. So this is the stuff that's happening 1,000 miles away.
Yes.
Because
There's
Colorado
a-
and Wyoming usually get really bad this time of year as well.
there's a fire in Pocatello area, but that's not what's bringing most of this smoke. This is the amazing fires in California.
Oh, okay. All right. That's incredible.
Unfortunately, this is a phenomenon. This is pretty bad. This is about as bad as I've ever seen it, but we often get smoke this time of year, unfortunately, because of wildfires.
Yeah,
Right.
and fortunately, the one year that was an exception to that was 3 years ago for the eclipse. It was
Yes.
perfectly clear blue skies this week. In fact, tomorrow is the 3-year anniversary of the eclipse, and it was just crystal clear. So we got one great August when we really needed it.
Yeah, boy, that would have been a total
'Cause
bummer.
we
Can you
had
imagine?
totality in Jackson, so it was pretty awesome.
But 2 days ago, it was very clear here too. So it was just the smoke has just arrived.
Crazy.
So let us take a look. We had a set of kind of a schedule that we wanted to take folks through tonight. And I think we should go ahead with that if we can. And maybe we'll use Sam's images in case we want you share your images, Sam. And we'll start off. What we wanted to do was kind of introduce what we were going to bill as, this anniversary of two major important events in the history of astronomy. One was the Great Debate that set the scale of the entire universe, excising the Milky Way as the center and the entirety of the entire universe. And then that was by discovery of the Andromeda galaxy's nebula, pulsing Cepheid variable that we talked about before you guys joined. But maybe first we'll go to take a look at, we're going to look at Saturn and Jupiter. Do we have any images of those guys, or Sam, did you not include those? Because I can bring one up really quickly.
Yeah, if you've got one handy, go for it. But I can grab some as well.
Yeah,
I'll
I have a
stop sharing
nice
so
one
you can
that's
do that.
yeah, I have a nice one that's a rotating GIF of the which I sent out in my email today to my viewers, to my listeners. Copy image. I want to copy that, and I want to paste it here. So I'm going to get out of here. There we go. So this is a composite set of images that I turned into a GIF, but let me share my screen here. So we wanted to start with Jupiter, and actually Jupiter is nice because you can really see tremendous detail even with a telescope on Earth, but certainly with the Hubble Space Telescopes. Can you guys see that on your screens?
We can,
Oh, yeah.
yeah.
Okay, so this is just one frame, which shows, of course, the famous great red spot down there. But also, even through a tiny telescope, Galileo was able to glimpse the moons of Jupiter, which he called the Medicean stars. I always point out he named the objects which he discovered after the funding agency that provided the resources to build his telescope. So maybe we'll call Mike's telescope, we'll name his discoveries the IEEE or something like that. Your funding agency. Well, most of our spouses have to be our funding agents. They have to allow us to spend their money and our kids to spend their inheritance. But you see the incredible rich structure. And it was rumored, I don't know if you guys ever heard the rumor that Galileo may have spotted the Great Red Spot, and that dates its age to at least 410 years old. This is the 410th anniversary of the discovery of the moons of Jupiter and the observation of Jupiter by Galileo, which I talk about often as being the first great debate, the debate that set the scale of the solar system and displaced the Earth from its central location where it had occupied a position since antiquity. So I think that's quite an amazing accomplishment for an Italian gentleman of the northern region of Italy. And with a small telescope, he was able to really displace the paradigm that it held for literally millennia. So Sam, do you have a picture of Saturn that you can show?
I actually have a
Yeah,
picture.
Okay.
I don't have
I
a
was just
picture of
gonna-
Saturn,
yeah,
but
go
I
ahead.
do have a picture of Jupiter from the Juno satellite that I made myself. But
Great.
I'll
I've
have
got
to
that
be
queued
able to,
up.
but I have to be able to get off of your screen here to find
okay.
it.
Stop the
There you
share
go.
there.
Great.
Okay.
I've got it queued up, ready to go, Mike.
Okay, go right ahead.
Were you thinking of the South Temperate Region one?
Yeah, we could do that one first. That's probably the most unique one.
Great. Okay.
Yeah, this picture, I'll just talk a little bit about it. It's taken by the Juno satellite. So it's the first time that we've ever seen. Okay, well, this is not, okay, this is the South Temperate region, all right?
I love these Juno pictures, man.
Yeah, well, I made this picture. Juno has left the processing of their pictures up to amateurs. They
That's
provide
right.
they provide the raw pictures.
Yeah.
And so this was a very difficult picture to make because Juno goes around the planet. It gets very close at the equator within several thousand miles, and then gets up to 60,000 miles at as it's going over the poles. So it has a polar orbit. This is 4 separate pictures taken on a single orbit from very different distances. So to make this into a single picture that captured pretty much the whole planet from very different distances was not easy. But
And you processed this yourself.
I did this. Yeah, this is my picture.
I'm going to put a link in the chat box, the live chat, to where you can get image processing software. This is from swriuno.edu. Juno. Right. So folks can click there and they can get they can try their hand to make an image like that. Blue Jupiter.
Yeah, they can get the raw images right from the Juno's website. And as I said, this was 4 separate images taken at very different distances. But it's a nice one because it captures the southern hemisphere. So I think it's about from 38 degrees south. You can see the giant red spot. You can also see the South Pole, which again, a viewpoint that we've never seen before until the Juno satellite. But you can just see
that from Earth.
Detail in the cloud formation. Now this camera on the Juno cam is only 2,000 pixels by 2,000 pixels. Wow. But it's an interesting camera because the satellite is rotating while these pictures are taken. So it's the whole process of acquiring making those pictures and acquiring them is not straightforward.
Do you guys know if the Juno cam was it installed on Juno kind of as an afterthought, or was that done? It was done strictly for, I think, citizen science, right? That was its purpose. But they added that.
It almost seems like an afterthought because compared to the other instruments on the thing, this is just a tiny little camera hung off the side of the satellite. I mean, I love it, man. It's the size of a single lens reflex camera. I mean, maybe a little larger because of it has some sophisticated hardware software to deal with the fact that the satellite is rotating while it's taking these pictures.
It's almost like they built this whole spacecraft to do this amazing science, and somebody said, "Hey, you know what, dude? We got to put a camera on here somewhere."
Maybe we should be able to see something.
Yeah, they have infrared cameras and ultraviolet cameras, and ways of measuring the gravity.
And magnetometers and all kind of stuff to measure all these non-optical things.
But the thing that people see most notably about this mission are the fantastic pictures that people, like myself and others, have made these.
I'll bring up the South Pole shot now if you want.
Yeah, the South Pole shot is probably it's the most unusual. Now there it is. So this is the first time ever, I mean, that anyone has seen the South Pole. I mean, I don't mean in this picture, but by the Juno satellite. And this again was this one was difficult too because the satellite only captured about a third of the South Pole on each of its orbits. So this was the first, third, and fourth orbit that the Juno satellite made that provided the raw data to make this picture. And so piecing that together again was not good.
So these are phenomenal. Mike, do you have any images of Saturn, did you say, or did Sam?
No, I don't.
Or,
I got a couple I can bring up.
Okay, yeah. Sam, why don't you take over?
So first, here's not a great image of Saturn. This one I took with my Droid phone, just holding it up to one of our 20-inch Dobsonian telescopes. No tracking, nothing like that. Just holding the Droid camera up there and snapping a picture through I think it was maybe a 25mm eyepiece.
Okay.
So just got the rings.
All right.
We're not seeing. Are you showing it?
Try it again,
sorry,
Sam.
can
Yeah,
I
we're
see
not
that?
seeing it yet.
All right, my bad.
Try it one more time because I
Yeah.
just allowed you both to be able to share.
No, I just forgot to re-click
And
it.
Tony, did you kill the stream on your channel? Did you end the live stream?
People are watching and I'm chatting on it right now.
Oh, okay, cool.
Yeah.
Can you guys see that now?
Yeah.
All right, so this is the image that I got with my Droid phone.
Well,
Yeah.
I got to tell you that the pictures that if it was clearer tonight, the pictures that we would be seeing live are about this quality. So it wouldn't have been a lot better.
Hey, that's not bad though. What was the eyepiece you had in there?
It was just a Meade 2-inch Super Plossel.
And that's
I
from
know, right?
That's pretty good. That's
my
not bad.
Droid. That's my Droid camera.
I mean, as old as I'm
It took
getting,
several tries. I was going at it for about 20 minutes. The trick was to get it just on the edge of the eyepiece. Actually, when the image was centered, I couldn't get it right. I couldn't get the rings to come out, but just on the edge, I could get it.
Pretty good.
That's
And
awesome.
I'll show you one that is a pretty incredible contrast.
Yes.
Can you guys see that one?
Well, I see Hubble Heritage down on the lower right. So yeah, it's quite a bit different.
Yeah.
You're not being fair to your
This is
camera
not the
phone,
most
man.
this is not my camera phone. Now this is the Hubble. This isn't the most recent picture that Hubble took. Actually, this one was from a while back. The most recent picture I think is even better because the rings are tilted at a real nice angle. But I have to share my favorite Saturn fact. So when we go, oh, go ahead, Mike.
No, I was just going to say the Cassini pictures of Saturn, though, are the most amazing. Anyway.
Yeah.
They are. But when we're out doing stargazing programs, and we have folks see Saturn for the first time, and their eyes kind of pop out of their head. They don't even think it's real, and I joke with them that it's just a sticker on the end of the telescope.
Right.
But what I love to tell everybody about Saturn is that if you had a bathtub big enough and enough water to fill it, you could stick Saturn in the bathtub minus its rings, and it would float because it's the only planet that's less dense than water.
That's right.
That's right. You guys can't see it in the meeting, but I'm showing the latest 30th anniversary image of Saturn from Hubble.
Awesome.
It's up there. Yeah, it's beautiful, man. It's really great. I don't know, man. Cassini did a good job, but Hubble can hold its own for a 30-year-old. I'll tell you, it's doing okay.
I think so.
Yeah. So next up, we wanted to take a tour through to look through a couple of other images that have been extremely important throughout astronomical history. And let me cue those up here. Let's see here. So I think the first one we were going to do is to go to after, now we're going into the realm of the deep sky. So we're going to look at some nebulae that are the result of the death of stars. So we're going to look at life cycles of stars. We're going to look at some young stars, some old gray-haired stars, and then we're going to look at some dead stars in the aftermath of a dead star. So I think the first one we're going to look at is the very famous Ring Nebula, which is right overhead probably now for many of our listeners, viewers, etc. And this is sort of an iconic nebula.
We're still seeing Saturn, just so you know.
I mean, I can try to point my telescope at it. Well, there it is. That's a picture from my telescope, but I could try to actually do it if we wanted to. I'm not sure how well it's going to come out.
Well, if that's the actual image, I think that's about as good as we can get.
Frankly, that is the image. And
you want to talk about that, Mike? You want to talk about what we're seeing there?
Okay, well, this is as Brian was just saying, this is the Ring Nebula, which is it's called a planetary nebula because it's circular. It has nothing to do with planets, however, and it's the remnant of a sun-like star. The sun is burning, our sun right now is burning hydrogen into helium with the release of energy. Once all the hydrogen is gone, it's going to, the fires are going to go up briefly, the gravity is going to take over, squeeze helium, and helium is going to start a whole new nuclear reaction. But after helium burns out and there's just left carbon, the mass is not big enough for carbon to begin another nuclear reaction. The star is going to lose its nuclear fuel, and it's going to expand into what's called a planetary nebula like this. And this one is one much like the sun, will develop in about 4 billion years. So we don't have to worry about it right away. But you can see this little thing in the middle is in fact it's called a white dwarf. It is not a star that is, it's not a star that's producing, it is producing light, but it's only because it's extremely hot and it actually is cooling down. And it's very, very dense. It's much denser than normal matter. Not as dense as a neutron star, but much more dense than the matter that we're used to. And the cloud around it is the leftover gas and dust from the star. And it's huge. I mean, this is probably multiple times the size of our solar system. And that's what's going to happen to the sun. When it finally, well, in fact, before it even goes into this stage, it's going to become a red giant. And in its orbit will actually, its size will actually encompass possibly as far as the Earth's orbit. So it will not be very comfortable living here on the planet in several billion years. But then once it finally loses all of its, the nuclear reactions end and the fires go out, this is what our star will turn into, the planetary nebula.
So now for some old stars, we want to take a look at something that had a lot of interest. This is a great globular cluster, M13. So Sam, you want to cue up a picture of a globular cluster? I'll talk a little bit about it while you do that. Then you can take over the screen. So globular clusters are extremely important. They really do indicate a great deal of properties, not only about the stars which they contain. They're kind of like, they're called globs because they're basically globes of stars with perhaps hundreds of thousands of stars within each one. They're kind of like mini galaxies, but they're not massive enough to have black holes within them. We'll talk more about black holes later. But one of the most important aspects of these globular clusters is the way that they're distributed around the Milky Way allowed astronomers for the first time to triangulate the position of the center of the Milky Way. And originally Herschel thought that the center of the Milky Way was centered on the Earth and the sun, and that's because of an illusion caused by dust, not unlike the smoky dust that we're experiencing here in much of the country. But the center of the galaxy was later found to be not located in our region of the galaxy, actually towards the constellation Sagittarius. And in a little bit, we'll talk about the center of the galaxy in Sagittarius and even show some animations of stars as they fly around the center of the galaxy, enthralled by the gravitational pull of the black hole within it. But now I want Sam and Mike to describe what we're looking at here.
So this is the most prominent globular cluster in the Northern Hemisphere. This is the Hercules globular cluster. Brian was talking about the position of these objects. So they're not in the disk of the Milky Way, where most of the stars are. They're actually in the upper and lower halos of the Milky Way. So this object is about 25,000 light years away from us. So to put that in perspective, when the light that you're seeing on this image that we took last week hit the detector in Mike's camera, that light had been traveling through space since the last ice age, 25,000 years ago. So it's way out there.
And Mike, what are those streaks?
These stars are ancient.
What are those vertical lines? You want to describe?
Yeah, they're because of the short exposure that we were doing, and so it's an artifact of the shutter closing and opening. When I take my long pictures that which are typically on the order of 10 to 20 minutes, you don't see those vertical lines. So it's an artifact of this camera is a cooled camera. Cooled meaning it's actually cryogenically cooled down to -30 C. It's not meant for taking short pictures, but I can take pictures as short as about 5 seconds. But that's about the time it takes the shutter to open and close, and it leaves these artifacts.
And Sam, can you say something about the seeing conditions that one would find when they come out to visit Wyoming stargazing sometime if they're so lucky? What's a typical
Yeah.
observing condition like here?
So, seeing refers to the turbulence in the atmosphere. And we have some pretty big mountains just to the west of us. And there's a lot of wind that comes over the mountains. And so even though we're at a high elevation, the climate is arid, which are great for astronomy and stargazing. The seeing conditions aren't the best in the world because of the wind that comes in over the mountains. So I think Mike actually calculated the best seeing that he gets through his telescope, which is about a few arc seconds. Was that right, Mike?
That's right, about 2.5 arc seconds. Yep. And
which is not bad. I mean,
no, it isn't.
Oh, go ahead.
No, it isn't, and it's not always that good. It gets as it might be 2 and 3 times that some bad nights, but this night here was well. This is I should tell you a little bit about these pictures. They're even this picture. Well, this picture is a single picture taken probably about 10 seconds, but the typical pictures that that I take and that are in the gallery in the library, for example, are hours and hours, in some cases as many as 70 hours. So there's a lot of pictures. And so I cherry pick. I take pictures every night that I can, and I assemble the very best ones that I can. And so, and I try to obviously pick the ones that have the good seeing, where I'm getting several arc seconds of seeing.
Yeah. So I think next it would be good to go from these globular clusters that contain perhaps, hundreds of thousands of stars, or, tens to hundreds of thousands of stars, and go all the way up to the billions and hundreds of billions, some say maybe even trillions of stars located in the great companion galaxy to the Milky Way, known as Andromeda Galaxy. And so, Sam, if you want to take a look at that and cue that up, and I'll say a little bit more about, I said some in the beginning when I was all alone flying solo when you guys abandoned me. No, I'm just kidding. But the images that we were looking at, yeah. So is this a Hubble image, Sam, or is this a Mike Adler image?
This is a Mike Adler image.
That's amazing. I thought it was a Hubble image.
Pretty
Sorry, folks. Right? Yeah. So I was describing that this is the 100th anniversary of the Great Debate, which wouldn't have been settled if an image like this by Mike had been available 100 years ago. Of course, it wasn't. And furthermore, it was the real subject of the Great Debate, whether or not this was a spiral nebula located in the Milky Way. And I often point out, things like comets, it wasn't known in the time of Galileo. It wasn't known if comets and meteorites were basically two different sides of the same phenomenon, namely that comets were an atmospheric phenomenon. And Galileo had some speculations in one of his great books called The Assayer is really about that. What is the nature of comets, and are they extraterrestrial in the sense of, outside in the solar system? And the debate was a very interesting one, to be sure. But the next great debate was this, how do we know that we live in a galaxy, and is our galaxy all there is? And of course, by finding a great Cepheid variable pulsing on and off 197 years ago, it turns out, 1923, Hubble was able to establish a distance ladder that went all the way out to here. And I just love this image because it shows so much rich structure. It's kind of like a selfie of what our galaxy would look like if taken from far away. Mike, how long was this exposure? What did it take?
This was on the order of about 12 hours of exposure. And the camera that took this, as I mentioned, is it's actually a black and white camera, but you get a color picture like this by taking separate pictures, first through a clear filter, and then taking it through our red, green, and blue filters. And I might take as many as, well, in this case, it was probably about 30 pictures, 10 minutes long each, through each filter, and then you assemble it into a color picture like this. Some of the other features of this picture. Well, let me just say something else about this picture in general. This is what really got me interested into doing astrophotography. I looked at pictures, like this, maybe as good, maybe not as good, but I wanted to be able to do a picture like this. And so that's what kind of got me started. This was taken, by the way, not with the 20-inch telescope. This is why, as Brian was saying, aperture fever, big telescopes can't take a picture like this easily. This is a fairly large object in the sky. This is like 6 moon diameters end to end. And so this was taken with my 6-inch telescope, a refractor at 900 millimeter. And whereas the big telescope, the 20-inch, is 3,500 millimeter, 4 times. You would only get a little piece of this. You could eventually get a picture like this, and it could be fantastic. But you would have to make probably, instead of just one 12-hour picture, you'd making, 6 or 7 large pictures, and then trying to make a mosaic of it. But the refractor, of course, is an extremely beautiful instrument. And it has extremely good optics, and so you get extremely good pictures out of it. The stars are just pinpricks in this picture.
And Tony, are you familiar with the PHAT survey? PHAT?
Yes. It's I could pull up the mosaic that Hubble took, like 500 images that Hubble took to put it all together. What is it called? Panoramic.
I put it in the chat.
Hubble.
It's archived. I put it in our chat. You can click on it in the chat. Check your Zoom chat. I'll put it in the live chat as well. It's right there. And
I do have. I'm not sure it's worth it, but I do have. Samuel asked me if I can put it instead. We were going to try to look at this tonight through the 6-inch telescope, and I do have a picture of what that would have looked like had we done that. But it doesn't look quite as nice as that nice color picture.
Yeah, I love this color image. So Tony will bring up the PHAT survey, Pan-Chromatic Hubble Andromeda Treasury, I think is what it stands for.
Yeah, I've got it up on Hubble site now. You guys can't see it, but it's up on the stream. And
okay. I'll put my screen up. Actually, let me share mine because I got it up on my screen too.
Oh, okay.
Okay, good.
Yeah.
So let's share that. Okay. So yeah, that Pan-Chromatic Hubble Andromeda Treasury is this region I'm showing here, the magenta. Can you see that, Sam?
Yeah.
Yeah.
Okay, cool.
We can see it. Yeah, I can see it.
Yeah. So this is a huge thing. So Tony, were you at Space Telescope when any of this was?
Yeah. They were doing it while I was there, and I would love when I'm going to talk about here in just a minute. I'm just trying to get there's an image that shows every single pointing that Hubble took to take that. As you can see in that magenta rectangle that's there, that's all it imaged. And it's interesting because they backdrop that on a Spitzer image of the Milky Way, of Andromeda. So that's an infrared image behind it. But every single star in the PHAT image is resolved. Okay. And it was it took several hundred pointings of Hubble, many dozens of orbits to take that thing, and it is the highest resolution image of that section of M31 that exists. And if you go to I'm going to put up my little thing here that I was showing. So here is the Hubble site thing of it, and if you click on the image itself, you can get resolutions. As you can see here, you can get a TIFF and a JPEG image, 17,000 by 8,000, or I'm sorry, 17,000 by 5,500 of this region, and you can scan it. And there's also a zoom thing you can do online as well to take a look at this. But this thing is amazing. Every single star in there, can't see it on the stream, but you zoom in, you're going to see the individual stars in the Andromeda Galaxy. So it's actually pretty amazing. So I mean, this is a quick image of it here.
Yeah, I should mention that the stars that are on the lower part of that and above the part of that, in fact, all the stars that you can see in my image are not stars in the Andromeda. They're stars in our Milky Way in front of the Andromeda.
That's correct. That would be, yeah, in this image I'm showing here, it's these bright stars here.
Yeah,
that you can see in the foreground.
What you're saying is, though, that the actual individual stars in the Andromeda galaxy can be resolved.
That's what I'm saying.
Yeah. Let me try and get
That's
that
the
up.
amazing thing.
Let me go back to that. Let's see if there's an archive that there's 23 bricks and each, yeah. So do you have a sense of any of the, yeah, here's one with all the pointings of it. I haven't shown that yet. Let me share my screen there. Shows all these different pointings. I guess there's 26 of them. And they're quite, you can hardly make out the, spiral structure of Andromeda from this low resolution image. But then, yeah, each one of these, I suppose,
7,400 exposures taken over 411 individual pointings. So
yeah.
400, and that's each pointing is a Hubble exposure.
So, and they covered the core of the galaxy there too. So it's just really fascinating that this galaxy is so important to astronomy for 100 years. And the nice, connection between Hubble's first target that really set him on a path to the fame that he has to garner the name of a telescope. And then to see the amount of effort by scientists around the world to go deep and study these pointings, as a treasury, as it's rightfully called, is just phenomenal. So respecting Tony's time, since it's getting late, I want to talk about a galaxy near and dear to our hearts, which is, of course, our own galaxy, the Milky Way galaxy. So I'm going to switch over to a different slide. Maybe, do we have any images, Mike, of the galactic center, or Sagittarius A star, with your instrument that Sam could pull up?
No, we don't. We were going to do that tonight, but we did not. So.
Yeah, we got smoked out. So this is an extreme zoom in 2 different formats. This is infrared, and it's also an X-ray inset. So this is taken, I believe, a Spitzer, and then the X-ray inset shows the close-up is basically all you can see with light, gamma ray, X-rays, etc., electromagnetic radiation for now. And that's shown here in this X-ray close-up. This is taken by the Chandra satellite. And this shows a tremendous amount of structure that's located in something that's so infinitesimally small, you can't even comprehend it. When you look up, if you're blessed to be in a location that's not under siege by forest fires, you could see the center of the Milky Way galaxy in the constellation Sagittarius, which has this famous teapot-like asterism that makes it so noteworthy. And if you zoom in X-rays, you can see this image. And if you go even further into the center of this and you get rid of all the gas and the glowing nebulosity and even the X-ray emission, and you look right near the center where there should be nothing, i.e. a black hole, you in fact see something very interesting. And can you guys see this animation that I'm pulling up? Okay, so this is made by a group at UCLA that's called the Keck UCLA Galactic Center Group. And they've been monitoring the galactic center, monitoring the orbits of stars as they go around the putative center of the Milky Way galaxy. And there's a whole bunch of very interesting structure. They've been doing this for about 20 years there. And you see in the lower right, this 0.1 arc seconds. That shows you how fantastically small these images are, and the resolution that they have to get really require dramatic advances in what's called adaptive optics. Mike, do you have an adaptive optics rig on your
I
setup?
do not.
Yeah.
No.
So it's really an advanced technology that uses deformations of mirrors and sort of a flexible wavefront correction that allows you basically to remove the atmosphere of the Earth and get images that rival the Hubble telescope, right, Tony? I mean, the seeing of these images is comparable to or better than the CCD resolution that was placed in the Hubble back in the 90s. So it's really phenomenal. What
you're talking about the adaptive optics on Keck?
Well, I'm talking about do you know what the angular resolution is of the
Hubble?
Yeah.
No, not off the top of my head. No.
Yeah.
It's
So
pretty good though.
Yeah. So Andrea Ghez, who's the leader here, she's a fascinating scientist. She's really an amazing person. Like Mike, she went to MIT, a small technical college, somewhere in Cambridge, I'm told. And then she went to Caltech, and she's been in Los Angeles for a long time. She won a Genius Grant. I've heard her speak. Tuan Do might be watching, I don't know. He's a huge leader of this project. He's very active also in scientific communication. He's a fellow in many different postdoctoral and astronomical. So these are friends of mine, colleagues, coworkers in the UC system. Many of these, Jessica Liu, who's at UC Berkeley, they do just phenomenal research by basically allowing the atmosphere to be removed using this very clever technology that Andrea and her group have really pioneered. And so by monitoring the orbits of these stars, you see the absence of a star right here. And that's the galactic center's black hole, which we call the Sagittarius A star. But these are taken over, I think, about 20 years. And then there are other objects in here that are labeled like SO2. Those are blobs of gas, which every so often get close to the black hole. And you get these notices on Twitter, look out, there could be a big, explosion from this gas cloud as it gets eaten by the black hole at the center. And that's never happened so far. But actually, I think I'm covering up here. Here's the dates in decimal years. Starting in 1995, she started doing this. I remember that. And so you get many, many complete orbits, which allows you to identify the location of what must be found to be a black hole. By the laws of general relativity, there's no other source that can cause these behaviors of all these various stars to orbit in just this way. So it's something you can't see with an amateur telescope. You can't even see with the Hubble telescope. It's really only something that's possible thanks to these adaptive optics on large ground-based telescopes. And of course, there'll be some new ground-based telescopes hopefully coming up in the new decade, including the Giant Magellan Telescope, hopefully the 30-meter telescope, and many others. So there's very interesting science. And of course, this black hole is Tony or Sam or Mike, do you know how many solar masses this is? It's not as massive as M87.
It's about 500 million.
Yeah, so it's quite massive, and it will presumably be the next target of the Event Horizon Telescope. So I'm going to look that up. Sam or Mike, you want to add anything about this object before we move on to other aspects of stellar evolution?
I think the only thing I would add, it has not about this object, but just flashing back to the Andromeda. One of the other amusing things about Andromeda is that the Andromeda Galaxy and the Milky Way Galaxy are going to actually collapse into a single galaxy in about 4 billion years, which is about the same time the sun is going to wink out too. So it'll be interesting times.
Keep paying your taxes.
Also, dude, I just got to say it because I said it wrong. 4 million solar
4 million, yeah. I thought it was
400.
Maybe a little bit bigger.
I just got to correct myself there. Sorry.
So there's M87 there, which you can see in the spring, right, Sam? Or when can we see? I think it's in Virgo.
Yeah, we actually took some pictures of M87 a couple months ago during our virtual stargazing programs. It's a bit too low in the sky right now, but you can't actually see the black hole with Mike's telescope like you can with the Event Horizon Telescope. But we could actually see the glowing core of M87 in which the supermassive black hole resides.
It has tremendous jets that stream off, actually far larger. I'm told here's an analogy that I heard in a book by Becky Smethurst, who's Dr. Becky on YouTube, who'll be on my podcast this coming Monday or recording on Monday. She has a wonderful analogy in her book, recent book, like Space at the Speed of Light, I think it's called. Anyway, the book's great. I don't remember the titles very well, but she basically says if M87 shown here were a grain of sand, the actual black hole would be a speck the size of an atom on this image. So this whole galaxy is a grain of sand. And then the jets, which you can only see just the very, very most tenuous outlines of here, would extend the distance of your palm. So it's just an amazing way to think about how much power this black hole has to extend something out, a good fraction of millions of light years, perhaps from its galactic center. So I'll get a picture. Let me see if I can get M87 galaxy.
While Brian's doing that, I'll just say one more thing about Sagittarius A. The cool thing about that is it's, although you can't actually see the black hole, that part of the sky is visible right now. So if you look to the south, you can find the constellation Sagittarius. It looks like a teapot. And the Sagittarius A black hole is just up in the right-hand corner of that, that constellation. So look to your south on a clear night and this summer, and you'll look right in the direction of our galactic center.
Yeah. So let's start coming down now. I want to talk about two more nebulae, and then we'll finish up with some very long exposures because it's getting very late for poor Tony on the East Coast. And then we want to give away our door prizes, so I'll give Sam some time for that. Let's talk about the Eagle Nebula, the M16, Messier 16. Sam, do you want to call up Mike's greatest hits on that?
I do.
And I don't know, do you actually have the non-greatest hits? Do you have the the real-time exposure from last weekend's observing? And then
I think we do.
oh, okay, great. Yeah, I'd love to see that.
I've got the color one right here. Mike, do you have the black and white one?
Okay, I was wondering about. I can produce a black and white one quite easily while you're doing this. So let me do that. Why don't you show the color picture? And
I will. Here's the color shot of the Eagle Nebula. And in the center, you've got the famous pillars of creation, made famous by a picture from the Hubble Space Telescope, I guess over 20 years ago, right, Tony?
Yeah.
1995 was the first one. Yeah,
25 years ago. Yeah.
Yeah. It's funny how it became iconic with Hubble. I guess it was one of the first ones where people just saw an image from Hubble and went, whoa.
Yeah. And so
Hubble also took a picture in 2014 too. So with it looked quite similar, but if you looked at it in detail, you could actually see differences. It was interesting.
Yeah.
And so those pillars are several light years long, right?
5
light years.
Yeah.
So 30 trillion miles long, those pillars. And that's where we get stars. These emission nebula are the stellar nurseries of our galaxy and of every galaxy. Stars are born out of these collapsing gas clouds.
Yeah, if you want to, at some point, you want to. I have a picture of what it looks like through the telescope. What we would have seen tonight had we looked. Yeah.
Yeah, let's look at that because I think people get a little spoiled when you see things like this, which is the result of 68 hours of exposure.
Well, this is not the 68-hour print though.
Oh no,
Samuel, do you have that one?
I do. We can get to that in a minute, but yeah, let's do the black and white.
Okay,
one.
the black and white.
So you have to. See, can I share my screen?
Yeah, go
you
ahead.
should be able to.
Okay,
you
all right.
Be able to now.
Okay. Okay, so here's my screen. So here it is. So this is like a 20-second picture of the Eagle Nebula, and I can blow it up a little bit. So you can see the same features that we were just looking at, but so this is 20-second picture, but to get the detail that you saw in the previous one and one that Samuel will show, which was my 68-hour picture. What I did was that picture that Samuel showed was probably on the order of 15 to 20 hours of exposure. And it's also done in narrowband to capture the detail, which shows emission of just hydrogen. In that picture, the green was hydrogen gas, the blue was oxygen gas, and the reddish color was from sulfur. This is actually just a picture of the hydrogen emission itself alone in black and white. And that's what we would have seen pretty much tonight. You can see the other major feature. This is called this is the pillars of creation, but this is also called the fairy of the, which is another amazing picture. There's some beautiful Hubble images of the fairy of this nebula as well. Let's see. You were asking me earlier, since we're on my screen, let me show you a few pictures. This was a picture of the M57, the nebula that we looked at earlier. And this is more of a process picture. You can see it's in color, and you can see a little more detail. It's not just a white ring. There's actually detail in that ring. And so this is a process picture of that. And the last one I was going to show is what we would have seen had we looked at the Andromeda through my telescope this evening, my 6-inch telescope. So this is an image from my 6-inch telescope of the Andromeda. And you can see, you can't see all that wonderful detail that we could see in the finished picture, but you can see, we would have seen these bands just like this. We would have seen the spirals in the Andromeda galaxy. So, and this is another galaxy, and this is another galaxy. These are satellite galaxies of the Andromeda.
Yeah, yeah, those are also in orbit around the center of, presumably, the black hole that lies at the center of the Andromeda galaxy. Of course, we're not seeing most of what's there. Actually, most of what's there is dark matter that's really making up, 5 or 6 times the amount of the luminous matter that we can actually see in images like this. That's the result of conversion of nuclear material into heavier nuclear material in the fusion process. Speaking of dark matter, I know that you have a picture of the Whirlpool Galaxy M51, which we had hoped to see. Maybe Sam, you can call that up, and then that'll kind of take us home while Mike maybe gets his last image, the long exposure of.
Well, Samuel has that one, so I'm going to let him.
Okay.
Yeah,
great.
If he has that right away, we can show that now. If not,
I've got M51 up first, and then we can.
Sure.
Yeah. So there's the Whirlpool Galaxy, M51. It occurs to me that we've mentioned numbers with the letter M in front of them a couple times tonight, but maybe we haven't explained what that M means, and maybe some people don't know. The M stands for Messier. He was a French astronomer who was obsessed with finding comets, but he created an incredible catalog of all the fuzzy spots in the sky that turned out not to be comets. And so we have as his legacy the Messier catalog of 110 of the brightest fuzzy spots in the night sky, which include almost all of the objects we've looked at so far: the Ring Nebula, the Eagle Nebula, the Andromeda Galaxy, the Hercules Globular Cluster, and now the Whirlpool Galaxy. So it's his legacy that we have this great catalog of all the bright fuzzy spots to look at up there in the sky. Mike, do you want to add anything about M51?
Well, M51 is an interesting galaxy. It's one of the iconic galaxies. Everyone who has a telescope has to take a picture of this because it's so beautiful. And there are 2 galaxies here, actually. This galaxy here is a separate galaxy, and it's rotating around this galaxy. It also stretches M51 out, so it's more length, it's long, it's more long than it is wide. And it eventually will merge with M51 in probably maybe under 1 billion years. Unlike what I was describing earlier, when the Andromeda and the Milky Way merge, now they're much further apart than these 2 are. We're 2.5 million light years apart, and so it's going to take 4 billion years for that merger to happen. But these are going to happen. This is going to happen much sooner than that.
Again, keep paying your taxes out there, everyone. So the last one, let's look at that long exposure image of M16. And then Tony, maybe you have a few final words before we let you go to bed and tuck in your nightcap.
Yes, I'm not that tired.
Okay, I can keep going. These guys are.
I even get
early
comments.
here.
Asteroid Hunters on Twitch is like, Tony's ready to pack it in. I'm just listening.
He's just chilling. Actually, do you have any questions on your chat, Tony, that you want to?
No, people are just chat with each other and just kind of enjoying the
cool.
pics. So, Yeah.
Yeah, everybody's
Oh, yeah.
loving these images, Mike. These are just phenomenal. Some are comparing it. My friend Miguel Yeti Tears is talking about how these are, kind of the art of the cosmos, God's art almost. It's just so phenomenal that you're able to make these images. So yeah, let's. What are we looking at now, guys? I see the Ring Nebula again.
Yeah,
Well,
so
they're both the Ring Nebula. Yeah.
Oh,
Yeah, this is the Ring Nebula, pretty much the one we were looking at had we looked at it through the telescope tonight. It is just the type of image we were seeing.
yeah.
And you can see the center star, and you can, which is the white dwarf. You can see another star there. And here, this is a 70-hour exposure of this. And you can
Wow.
see that it's a flower, and it extends way beyond.
Yeah.
So there's a lot more to this nebula than is visible with the naked eye, or even really fairly long exposures, 10-hour exposures. You won't see these double ring beyond the center.
Yeah, these are all shockwave and turbulent phenomena on the different gas layers, which are the result of the last stages of the explosive end of this star as a nova, shedding its outer layers, and this beautiful cascading turbulent flow. It's so rich in structure. That's really cool. Yeah, you can see it. You can see the two stars in that image very clearly, and they're illuminating with different colored photons, and you can see even like a very thin shell of violet, which is just spectacular.
Yeah,
So-
in this, the
Mhm.
atomic colors here, that red is hydrogen, that violet is coming from oxygen, and there's a green tinge to this out here, makes it look orange. That's sulfur.
Amazing. So
By the way,
yeah.
you can see this little guy up here too. This is another galaxy that's way off in the distance. I have no idea how far away it is, but it's,
Oh wow.
it
Yeah.
could be hundreds of millions of light
It's
years.
photobombing the Ring Nebula. Wow. I've never noticed that. Wow. Certainly never seen it with my my 2-inch diameter Meade telescope. So Sam, why don't you show us the last image of the night with a very long exposure image, I believe, of the Eagle Nebula, Pillars of Creation, and then we'll close it up.
I think this was the long 68-hour exposure that Mike had for us. Mike, did you
Okay.
have a long one of Eagle as well?
Oh yeah, of course. I thought I did send that to you, but yeah, I can bring that up. So you're going to have to let me share my. Well, let me just.
You can share now.
Okay, very good. I'm going to. I just have to bring up. I have the. Yeah, that was that image there was about 70 hours. It's my absolute longest image, and.
Obviously not all at once. It's broken up.
Not
over
at all
several
one. Yeah,
days.
needless to say, not at one night. These are in fact, that image, I started taking pictures of the M57 probably 3 years ago. And what I did this year is I added probably 40 more hours to it, which allowed me to see that large that stuff you're seeing way out on the outer edge. And I'm just going to, without.
Yeah, Tony, how does it
document.
compare with the Hubble Ultra Deep Field and Deep Field? Do you have a recollection?
How long those images were?
I think those are about 100 hours.
They
right?
were Hubble typically does 100-second exposures, and it depends on which deep field you're talking about. They've taken a lot of them now.
Yeah.
But it depends on how many orbits. Like Frontier Fields just took 6 more Hubble Deep Fields, which I don't have the numbers off the top of my head, but we're talking in about 100-second exposures each, and a 90-minute orbit is when they're allocated observing time. So they build these up, over weeks and weeks. So it just depends. I don't know.
Yeah.
I think the first Hubble Deep Field was the equivalent of 10 days of exposure time.
11. Yeah, that's right. It was taken between December. That one I was going to talk about when I leave. It's December 18th to the 28th of 1995.
Yeah,
and,
I'll show that on my screen now.
Yeah, so it was taken over 11 days, And the image is less than spectacular. I'll show it in a minute. Well, okay, you'll show it now. Yeah, that's my favorite Hubble image. It's not the most beautiful. It's not even close, but it's when you look at that image and understand that when they took it in 1995, they did not know that they would see anything at all. This was pointed at a region of the sky where they did not know anything to previously exist. And the field of view of Hubble is so narrow that if you hold, it's like holding a grain of sand in your fingers held out at arm's length. That's how much of the sky Hubble subtends. So it sees tiny areas of sky. And here they used all these orbits, all these days, 11 days, and came back with that. And it was a risky image. It was taken with Hubble, it's taken with the Institute director's discretionary time. He has 20% of Hubble time available to him that he can use for anything. And he decided in 1 year to do this. And people were actually kind of mad at him about it because this was a risk. Why are we wasting Hubble for 11 days on nothing? And look at that. I don't think there's a single image out there, I don't care who you are, that puts perspective on the cosmos better than that one.
Yeah, it's truly phenomenal. And they followed up the ultra deep field, but this, we call this, oftentimes the cosmos's wallpaper. Let's see if this will work. I'll get some ad for some kind of blue colored pills that YouTube knows I like. Okay, let me see if this will go full screen. There it is. Oh, so now zooming in, as Tony just said, on this microscopic region. And every single bit of light you're seeing, Tony, right, is a galaxy. There's one or two stars.
Every dot, smudge, and smear in the Hubble deep field is a galaxy. There it is. That's the ultra deep field there. You can tell the difference because it was taken with a wide field camera 2, I think. The original was taken with PIC 2.
Right.
So it's a different camera. But yeah, that's it. That's every single thing in there is a galaxy. Every single one.
Just count them up.
Stars in that.
A trillion galaxies, right?
Yeah.
Depending on the image, that one might have 11,000 in it. The original Hubble had like 5,000, 6,000 galaxies in it.
So let's see. Do we have a final image to share?
Yeah, we do.
Okay.
So if I can, let's see, share my screen. I gotta find Zoom here again. And where is Zoom? It's buried on my screen somewhere. I've got too much. I got to close up some windows to find Zoom. Zoom it.
Adler Ultra Deep Field.
This is my ultra deep field. It would be interesting to have a image of the pillars of creation done by Hubble. Now, maybe Samuel, you could bring it up on the web while you're doing that. I could, in some ways, that would be nice to show that first, and then maybe you could pull up a Hubble. Hubble.
And I got it here.
Okay. And I was just thinking, while we're waiting for Mike to get that image up, I'd love to have everyone see what Mike's observatory looks like and the actual telescopes that he uses to take all these amazing images. I put together a little 1.5 minute video that highlights them that I could share with everybody right now.
Yeah, why don't you share?
All right, and you guys can bring up those other ones.
Yeah.
All right, here we go.
Hey everybody, Samuel Singer here, the founder and executive director of Wyoming Stargazing. I'm here with the vice president of the board of directors, Mike Adler, and we're here at his house and his incredible observatory. He's been helping us out doing some virtual stargazing programs using his telescopes in there. So we're going to go down and check it out.
The observatory is unusual because it's called a clamshell, and it totally opens. And so you can have more than one telescope in it. A normal observatory that you see in pictures has one telescope in the middle, but this one I can have 3 telescopes because it can be completely opened. So what we have here is the 20-inch telescope, and It's a bit of a monster. It weighs, probably close to a couple hundred pounds. This is my second largest telescope, which I use mostly for visual use and also looking at the moon and the planets. This telescope is my smallest, but it's a very useful telescope because a lot of the objects in the sky, the deep space objects we look at, are quite large, and some of them are many times the size of the moon. And so you need a telescope like this to get so you can see the full field of view.
Join us for virtual stargazing programs via Zoom on New Moon Fridays throughout the year.
Very cool. All right, I'm going to share my screen of the pillars of creation from Hubble, and then we'll look at Mike's, and then we'll be wrapping up and tucking in with a cup of hot cocoa, at least in my case. So this is an image from video from space. Can you guys see that, or is it frozen?
We got it.
So here's kind of a tour through these pillars of creation, as they're called, and that's because these are star-forming regions. And we believe that to have a planet that could host life, you need to be able to form certain stars that have just the right properties to allow for life to form, so to speak. So this is these pillars of creation have kind of become an iconic image. That's the most famous image, I think.
Yeah, that's it right there.
You see some light, but you can see the very complex fluid mechanics that's taking place here as you have boundary layers, shock fronts, illumination, tons and tons of dust and soot and so forth that will later become the seeds that generate new planets, new solar systems, perhaps with them looking back at us. And you can see the kind of inner shape here that Mike had showed before, and now it's zooming out to show the entirety of the Eagle Nebula. And really, this is the core. This is the interesting, very interesting region. And then these are other regions that Hubble has imaged, looking for allied phenomena, such as displayed here.
When you saw the fairy over there on the left that I was talking about earlier.
Yeah.
Right here. Yeah.
So great. So let's look at Mike. Now,
okay. Now it's not. It's needless to say, this is not my image. Is not a Hubble image, but it is. I will share it.
It's a little less expensive.
Expectations managed.
Okay. So here it is.
Hey, that's amazing.
Yeah. Isn't it amazing?
So
that's pretty nice.
And
slouchy, I'll tell you that.
Yeah, and so here's the fairy, and here it is, and I can zoom in some on this.
Yeah.
So you're seeing some of the same structure you were just seeing on the Hubble. These patterns that are in this part of the pillar, and as well as let's see if I can practice. Yeah, up here. So, it doesn't have the sharpness of the edges that the Hubble does, but I haven't seen in an amateur photo this much detail in the pillars.
Yeah, don't forget Hubble is looking directly at this object, if you will. And here in Jackson, Wyoming, you're looking through an atmosphere. Even though you're at about 6,000 plus feet, you're still looking through 80% of the atmosphere, and the water vapor and turbulence. To get such an image is just spectacular. And that's why I wanted to share with you this wonderful opportunity. I don't know. I know that there are many, many great amateur astronomers who take wonderful astrophotographs, but I've never met somebody that can take pictures like this. And so I'm really blown away as a professional astronomer. And I think, judging from Tony's reaction, he too can testify as a professional. These are really outstanding quality. So we hope that tonight's been really interesting for all the viewers out there. There are hundreds watching in different channels, staying up late. And I want to first thank Tony for co-hosting and giving us the insider's glimpse of what it was like to be a part of some of this and processing some of these and being around Space Telescope.
Yeah,
thank you.
Can I just ask you a quick question, Brian? Somebody wants to know where that link is to the some of that processing software you were talking about, but this was from Gen 7, but I don't know if he's talking about the Juno Cam software or just the processing software that Mike uses. Did you post a link?
I posted a link to the Juno software earlier, but
on your
on my
chat?
stream, yeah,
Okay,
in my
all
live
right.
chat.
Okay.
And I just
If you
thought
wouldn't mind just maybe emailing it to me, I can't get to the
Okay,
But
yeah.
meeting
all
chat.
you really have to do if you want to access those photos is just do Juno Cam NASA or just Juno, and you'll get to the NASA website.
That's good. Yeah, that's a good idea.
I'll post it again in my chat
Okay.
now,
Yeah,
and I'll
thank
move
you.
to Tony. I'll go to you as well.
Yeah. Okay.
So Sam, you want to tell the one lucky viewer or watcher submitter who is located in the United States? We have to be cautious because it is very expensive to ship outside of the country. So we had a bunch of people register for this, and I said there'd be some giveaways. And I want to ask Sam to give away or to announce the winner, and then hopefully that person will be in the United States. And if not, we can we'll have to redraw another one, but stay tuned for that. So Sam, you have the list of entrants.
I do. Yeah, I've got the list, and then we've got 4 door prizes. The first 2 are a couple Wyoming Stargazing stickers made by some local
Maybe
artists.
not share your screen so we can see it better.
Oh, okay, sure.
Yeah.
Is that
I'll stop sharing.
that's Mike's screen? Yeah. There we go.
All right.
Yeah.
Thank you.
So yeah, a couple stickers made by some local artists here in Jackson, Holly Sage Art. We've got the last remaining Wyoming Stargazing kendama. This is the last one that's ever going to be made. So if you walk away with this, it's going to be a collector's item. And then Brian mentioned earlier, the grand prize, door prize, is this incredible print of the Elephant Trunk Nebula that Mike made with his telescopes. So we'll get some names drawn here. I'm just spinning a pen on the list of names, and we'll just see where the pen points.
I even made the frame to that picture.
Oh, nice. Okay, so the winner of the first Eclipse sticker is Chris Munson. Chris, if you're in the U.S., please.
Chris is not only in the U.S., he's in San Diego in my office because he is my coworker on the Simons Observatory.
Excellent.
Congratulations, Chris. And I didn't have anything to do with it. Trust me. Yeah, come on, Tony. You gotta believe me. You gotta trust me, Tony.
Oh, okay.
All right, here comes for the second sticker. We've got Brian Christie for this this sticker right here. Brian, if you're in the U.S., just put a quick note in the chat for us so we know. All right, so now for the kendama, we've got Christopher Ellis.
Another one of my employees. Actually, now he's a graduate student in Reno, Nevada, University of Nevada, Reno.
Oh, nice.
Congratulations. These Chris's that work in my lab, they're super successful.
All right, and I promise I'm just spinning this pen and it's just landing.
Well,
where it
I did
lands.
get the vote out. I mean, I did put out.
All right, so here's for the grand prize for Mike's print. And we've got Brianna Jimenez. Congratulations, Brianna. So Brianna, just you can send an email to info@wyomingstargazing.org with your address, and we'll get that print to you.
Well, guys, I want to thank you all so much. This has been super fun.
Yeah.
I hope it's been valuable. We had a little technical difficulties, but that's been the norm over the last couple of months in Zoom land, tapping all the bandwidth that we're using. And so that combined with forest fires, COVID attacks, etc., looking out for.
I can never predict what's going to go wrong when I start a stream these days. It's just what things that work forever just stop working. And I'm like, what?
I know. It's
and
right.
it happens 1 minute before you hit the go live button. So sorry about
One of my
that,
friends
folks.
says this is proof that we're living in a simulation because everything that's going wrong can go wrong. I want to thank you. I want to encourage people to please join Wyoming Stargazing, donate. It's the 501c3 organization. If you're ever in Jackson, you must take advantage of it. It's one of the most exciting things to see next to having a moose chase after you. You'll never forget your observation through their gigantic telescopes. And who knows, you might be able to meet one of the best, if not the best, amateur astrophotographer in the world, Michael Adler. Thank you so much,
That was
Michael.
some nice work, Mike. That was amazing stuff. Thanks for sharing.
Yeah. So we hope to
Thank
do
you.
this more. Leave some comments on Tony's channel, my channel. If you guys want to see more of this, I'm hoping to do another one before the end of the year while it's still the 30th anniversary year of Hubble Space Telescope's launch. And also the 100th anniversary of the Great Debate. So I've been having all these debates about.
Okay, Brian, you've been talking. What debate? I don't know what you mean. The Great Debate. What was that?
So they called 1920. They called what was later called the Great Debate was the Curtis-Shapley debate, the famous Curtis-Shapley debate over the size of the Milky Way galaxy and the existence of extragalactic objects, such as what was later called first called the Andromeda Nebula, but then is now known as the Great Galaxy and the Great Andromeda Galaxy. So these took place in Washington, D.C. And if you look up the Curtis-Shapley debates, this is Harlow Shapley and Heber Curtis. And these were the first of not the first, in my mind, they're just one of many debates as to whether or not the universe is centered on the Earth, or human beings in some sense or another, either in time or in space. And this was what's really captivated the nation's attention for a while in 1920. So that being the case, we want to celebrate that discovery with the also concomitant discoveries that have taken place since then. So hopefully we're in the midst of another renaissance of astronomy. And everybody out there listening, watching all over the world, I want to thank you all for tuning in. Tony, thank you for co-hosting. Sam and Michael, good night. Keep looking up. Stay safe.
Thank you.
And tune in next time for our next virtual Stargate. I don't know if this has ever happened before, so this is kind of cool. Explains why we had some technical difficulties, but nevertheless, keep in touch, everybody, and please join Deep Astronomy, and please join Wyoming Stargazing and contribute.
Is did we say how to get a hold of all the Wyoming Stargazing?
I put some in the link in the chat. I'll put some in the description box as well.
There's also at WY Stargazing on Instagram, I think, is the way to get there. Okay.
Yep, I'll put all those links, all that in there.
It was a pleasure meeting you guys, and Mike, amazing work, man. A great setup you've got there too. That's an amazing observatory.
Thank you.
Yeah, it's really spectacular. So thank you, everybody. Have a wonderful night.
Thanks, everybody. Tony, thanks so much. Brian,
You're welcome.
thank you.
Bye, guys.